Hi there and welcome back to the cave. So here we are with the sim rig, and today we are going to talk about vibration, and not the vibration that the rig is passing through for force feedback, but the vibration that the rig is passing through to the rest of the house. So like all typical Cyprus villas, the place is just made of concrete walls, concrete floors, and then tiles on top. So as you can imagine, any vibration that's coming off the rig through the motion or through the force feedback, that's just going to reverb through the whole house. Now I don't really notice it when I'm sitting in the sim rig, obviously, but the wife and kids have certainly said in the past they can tell when I'm on the rig as the place rumbles and makes a noise. So I thought I was going to change the vibration pads on the floor to see if that can reduce it slightly, because when I first built the rig I used these thick foam mats that you can buy at the DIY stores for putting under gym equipment and things, but as you can see it is completely compressed down to probably about 1 millimeter thick, so it's not adding any insulation vibration resistance into the building. Now, as I said, I don't really notice it when I'm sitting in the rig, and the only time I've actually experienced it is when the kids have been on the rig and I've gone downstairs for whatever reason and I can hear it rattling through the house. And it's normal driving's not too bad, it's just that low sort of resonant rumble, but it's when you're crashing, you're going over curbs, or you're being lumped into walls or whatever it is, that's when you really hear it banging and clattering. So what I've done is I've gone and purchased these vibration pads off of Amazon. Now these ones are rated for about 50 psi, or 50 pounds per square inch. So for this rig here and the size of the footprint from the motion actuators, these are more than adequate for the use. So the footprint is approximately, the pads that come off underneath the actuators are about 3 inches in diameter, so there are absolutely no issues with the weight. God knows what the rig will probably weigh, but maybe close on 200 kilos if not more, spread across the 4 actuators. So yeah, there should be no issues with these 50 psi pads. And on the spec sheet for these pads, it reckons for impact hammers and things like that they're should be reduced to maximum 25 psi, so we're still well within what I'm expecting. So for vibration mentioning, I was like, well, how am I going to actually see if there's a difference, or how can I express how much vibration is coming off the rig? And then it reminded me that I do have these little Arduino Nano 33 IoT PCBs, and they have actually got an IMU or an accelerometer built into them. So I can put this onto the floor near the rig, but not actually on the foam or touching the rig, and see how much vibration is actually passing through the floor. So for these I popped onto Visual Studio Code, and using PlatformIO and a bit of CoPilot, I got it to set up a Wi-Fi interface, so it picks up a Wi-Fi IP address off the router in the office, and then it also set up a web server, so it presents that data on a trend back to the display into a browser, and then it also obviously reads the data off the IMU. So the IMU is sampling, I think it's 104 Hertz or something like that, so around about 10 milliseconds per sample, which is more than enough to capture any high frequency spikes of the vibration. So as I say, let's hop onto the rig, but let me first just set this up on the floor. So it's just a small, one of the old mini USB cables for this. It's such an old device, and it still works nicely. Just plug that into a standalone supply. If I can get it in, there we go. And then I just pop it on the floor, so it's pressing against the floor. And then to make sure that it's actually being held in place, I'll just put this battery from my drill on top of it, just to add a little bit of weight and hold it in place. And that's maybe what, 4 or 5 inches from the base of the sim rig. All right, let's hop on. So here we are on the sim rig, and the first thing is, you can see when I was taking that shot there of setting down the vibration sensor, that I could get under the leg of the actuator. And what I actually use for that is the platform diagnostic tool in Cubic Manager. It allows you to actually control the individual motors. So what I did is I set them all to one extreme. And you can probably see me moving on the screen there, and set the other one in the opposite direction. And that will actually allow me to then tilt the rig quite easily just by pushing it with my hand. And it will bring one of the actuators off the floor and allow me to get access underneath it without having to do any heavy lifting or anything like that. So that's how I achieve that. Right, so let me close that. I don't need this for the time being. And here is the web page that comes out of the Arduino. So this was all created by AI. I didn't do any coding at all. I just told it what I wanted and away it went, including the programming of the Arduino for the Wi-Fi connections, the web server, and for the reading of the IMU unit. And what it'll do is it'll scan. At the moment, it's just sitting there scanning at 500 milliseconds. But as I said, it'll scan up to the maximum of around about 9 point something milliseconds, so 10 milliseconds effectively. And it just reads in the 3 IMU values from the X, Y, and Z axes, and then it presents them on these graphs here. But what I've also done in this, or asked it to do, was to normalize the graphs. So when it first powers up, it finds what the 0 point is, because you can see the AX is sitting at 20, the AZ is sitting at 1,000, and the AY is sitting at -14. And what it'll do is it'll read those values when it's normalized, and it'll re-baseline the graph so that everything's running along the center. And every time I do a reset, it'll re-baseline that graphs. And then underneath the graphs, you can see we've got a session min-max. So if you look under this orange on the right-hand side, you've got a session min-max. So this is the maximum and minimum values, the red, from the time the unit was reset or the clear button was pressed. And then the period min-max is the min-max values for within the time frame of the scrolling trend. So whatever duration this is, I don't know what it is. I've never worked it out or counted it. But if it changes, for example, if a peak is maybe sitting up here, and that peak runs off the screen, the period min-max will drop, but the session min-max will remain. And then you'll also see there's dotted lines top and bottom. So that's the min-max also being drawn for the current period. So what I can do is we can fire up this down to 10 milliseconds. And you can see the graphs updating there. And all 3, and it'll just start scrolling continuously. And if I bang the rig, you can see vibration coming through the rig, through the floor, onto the IMU unit on the Arduino. So let's go out on track with the actuators off, then with the actuators on, and you'll see the difference the vibration is on the sim rig. But let me just sort out my displays here. Right, so here we are on the McLaren 720 GT3 at Sebring. Coming out the pit lane here, and I've got the motion system turned off, so the emergency stop button's pressed in. And we'll look at the graphs there. They're pretty flat lined, a little bit of movement on the right hand one, which is the Z axis. And what we'll do is we'll come out the pit, we'll come around that first corner, which is notoriously bumpy, and we'll see that there's not really a lot of movement on any of the trends. The X and Y we're not really bothered about. They don't tend to move much because we're only talking about the vertical vibration from the rig. I've got cold tires as well. So there we've got bumpy out there. Oh, I just about spun it there. They maybe warmed up the tires first before doing this test. But you can see there's not really a lot of vibration. We'll come around this corner and I'll run wide onto the grass, and you'll
there's still no real vibration. I'll feel it in the steering wheel, obviously, but you can see very little changes on the graph. Let's head back onto the track, avoiding these signs. And over this curb, I feel little kicks on the steering wheel, but nothing on there. And then we'll come down the straight and I'll hit the brakes for the last corner, and we'll probably see, I'll bring it to a stop. And you can see a little bit of increased vibration coming through there. So what we'll do now again, I'll go back to the start again. And we'll run that same bit again, but this time with the motion system turned on. And I'll maybe warm up the tires while we're waiting. Okay, so here we are at the last straight before the start finish straight. And the motion system's still off. The graphs are all pretty level. As we're not really interested in the two left ones, I'm going to turn them off, which I can do with these checkboxes. And we'll just concentrate on the XY, the Z. And I'll just reset the graph. And there we go. It's found its normal point. Okay, so what I'm going to do now is I'll turn on the motion system. And there's the actuators coming up. And already you can see that peak vibration kicking in just with the actuators finding their midpoint. So let's drive, and here we can see vibration going through the floor. From the motion system. My tires are a little bit warmer, but should have done another lap. Never mind. I'll come around this bumpy bit. I have a couple of spikes there on the grass. Oh, get away from that wall. So we'll do the same thing again. I'll run wide after this corner. Onto the grass. Oh, or I'll just spin it and hit the wall. Don't hit the wall. Don't want to break my wing. Not broken the wing. Right, let's go over the grass. And you can see the vibration. We go back on the track. Over this corner. I'll do the same back on this grass again. And you can see the vibration. And we'll do the same hard brake test. And you can see how much difference that makes with the motion system on. All right, so what I'm going to do now, I'm going to go and fit those pads underneath the actuators and see what difference it makes. Hopefully plenty. I'll go where my camera was there.
Alright, so here we are. So I've got three of the, you probably can't see it, but I've got three of the actuators set to min and one set to minimum, so it's tilted over to this back corner. And as you can see, if I just push the chair, it just allows me easily to lift the rig. So what I'm going to do is I'm going to take one of these and I'm going to slide it under the footprint, try and get it central to the existing mount. So tilt this rig, take this out, try and get that center to where it's currently sitting, and then pop this actuator out. Where am I sitting? And I think that will do it. I can always fiddle around with it. You can see that certainly taking a bit of the dampening. Now whether that'll make the rig move around too much or what, I don't know. So I'm going to repeat that for the other ones and we'll get back on the track again.
Right, so that's all four of the dampers, anti-vibration pads fitted underneath the actuators. And I've also just repositioned the rig back a bit. It looks like for the extra height, maybe when it was tilting forward, it's just a little bit closer to the screen. The pads are about 7/8 of an inch thick, I think is the spec. So it does raise everything up, and it's maybe, I'll see how it goes, but I might cut away the squashed foam from underneath the pads to bring it back down a little bit. Because obviously that's an extra height that's adding in there, and it does seem a lot more bouncy. I wouldn't say it's noticeably bouncy, but it certainly feels more movement there. I don't know whether that's a problem or not, but anyway, so we're in the car again. We're at the end of the last straight. The motion system's currently turned off. Let me reset the vibration trends. And there we can see it's holding steady around about the middle. Nothing really dramatic. Let's fire up the rig. And this time, we're certainly, you can see where the rig was turned on, but it was not as dramatic a spike as the last time. So let's come down the straight. So it's still obviously got vibration. Doesn't look as harsh. It looks a lot more flattened out, and the peaks aren't as high. It's good. The rig feels the same. I don't really notice anything different. I suppose when you're... So that big bumps there, you can see them on the trend, but not as dramatic as before. So it definitely is dampening out that vibration. We'll see what it's like when we come around this corner and go on the grass. Don't spin it this time. We'll go out onto the grass. And still see the vibration, but yeah, we don't seem to have the same peaks, I don't think. Oh, that was nearly a spin across this grass. Yeah, I don't think it's as harsh. I think it's definitely dampened things down a bit. We'll see how it goes. I might change. I might, as I say, cut the foam pads out. So it's just those vibration pads sitting straight on the floor. That might remove some of that flex. Or over time, the area that these vibration pads are sitting on the foam pads, it might naturally compress as well, like it did beforehand. So yeah, that's anti-vibration pads under the motion sim. Now let's do a brake test around this corner. Because we didn't do that yet. Let's do it at the end of the long straight. Let's see if we get the same. Right, let's cut this curb. Cut across here. Not really anything noticeable. A little bit of rumbles. A little bit of rumbles. And we'll brake hard at the end, right to a stop. And there we have it. All right, so I'm going to see how it gets on. I'll post the links to the pads that I bought from Amazon on the description below. I also put them in the Discord, and I'll also drop the links to the code for that Arduinos. So if you have got your own Arduino with an IMU, you can easily butcher that or do the similar thing and test your own rigs. All right, thank you very much for watching. I'm going to catch you later. Have a good day, everyone, and I'll see you later.